Hi, I'm Manusha. So we are working on the project called Cardiovascular Disease Risk Prediction, and this is our midterm presentation. So this is my team. These are my team members. So Fisa and Nida are the project developers, and Angsha is the business analyst, and I'm the team leader for the project. So our project is about developing a machine learning model to predict the risk of cardiovascular disease, and we'll be developing a user interface where the user can input the data and predict the risk, and we will also create reports and dashboards to answer the research questions. So this is the data we have. So far we have completed data cleaning, so where we have identified and removed the missing values, and we have replaced the ordinal categories with their string values, and we have detected and removed the outliers from the dataset. So here you can see that I have removed the dropped the values, null values, in these columns. So here we can see that the ordinal categories like gender, they are converted to their string values. So here this is the box plot for height. You can see there are a lot of outliers, and after removing it, the box plot is clean and neat. So next, Pisa will continue.
Hello. So till now, we have completed this activity. We have completed univariate analysis for all the columns. We have performed bivariate analysis to explore relationship between variables, and we have analyzed our data to find top 10 states with more heart disease. And we have compared the numbers of heart disease in metropolitan versus non-metropolitan counties and urban and rural counties. Next slide, please. So this is the screenshot of our univariate analysis for all the categorical and numerical columns. Next slide. So, and this is the screenshot of univariate analysis. So for general health, we can see that we have more individuals in our datasets who have very good general health, and we have very few people who have poor general health. And for BMI distribution, we can see that we have very few individuals who have very low and very high BMI, and we have more individuals who have BMI nearly 25. Next slide, please. For this is the screenshot of bivariate analysis. Next slide. And this is the visual BMI distribution versus heart disease. Next slide. Yeah, this is the weight distribution versus heart disease. We can see that as heart as weight is increased, heart disease is increased among individuals. Next slide, please. Now Angsha will continue.
Hi everyone, my name is Angsha and I am the business analyst in this group, in this project. So we have analyzed on state and county. So this is the code for the this is the screenshot of the code. So we have also analyzed the top 10 states with more heart disease. So we can see Washington have the highest number of users with heart disease. And we have analyzed on counties categories. So for metropolitan states, metropolitan counties has more user with heart disease, and in urban states, urban counties has a more user with heart disease. So we have also developed a user interface. We have designed it using Figma, and we have developed a fully responsive and user-friendly UI using Flask, and integrated with integrated clear input fields, radio buttons, and drop-down menus for easy data entry. And we have also added validation to all the fields. So this is the user interface looks like. So we have team communication through messages, team meetings, and through emails. Next slide. So issue and challenges. In this project, I faced challenge as I new to Figma. So I encountered challenges like adjusting spacing and ensuring a user-friendly layout wanted extra attention. So for addressing this issue, I watched some YouTube tutorials which helped me to navigate these challenges and refine the form design.
Hi, so this is Nida Sayed. So the current recommendations are to ensure data accuracy and consistency, for which the action steps are given. We'll ensure it's clean, the data is clean, accurate, consistent, and implement validations to maintain the data integrity and everything. And then it's the design user-centric dashboards, for which the action steps would be to design with a focus on usability, ensuring key information is easily accessible. Use clear labels, intuitive navigation, and enhance the user experience and everything. Next slide, please. So also for the to create interactive visualizations. So the action steps would be to develop tools such as drill downs, tooltips, and filters that enables users to explore the data, and ensure the visualizations not visually appealing but also provide meaningful and actionable insights. And also we have some action items for the enhanced model accuracy and reliability, which are to explore and compare various machine learning algorithms and to identify the most effective model for our data set. And overall, so the recommendation for the next phase would be the model evaluation. So we have to go through the model, create the model, analyze its performance with or without the other values, and if removing them improves the accuracy, we'll proceed accordingly. And for the documentation, we'll attach all the detailed documentation throughout the process. And also if we face any challenges or the decisions made or the rationale. And for the UI, we'll test the UI and verify its functionality, responsiveness, and usability. Next slide, please. So here is the project phase of the project hours and the cost. For the design phase and the development phase, the actual and the budgeted. So here's the budgeted hours for the design phase. It's 30, and for the actual hours is 26 for the design phase. And here's the 40 is for the development phase, the budgeted hours, and 36 is the actual hours for the development phase. And here's $1,500 overall budgeted cost for the design phase, and $1,300 for the actual cost for the design phase. And for the development phase, $2,000 for the budgeted cost and $1,800 on the actual cost. So the overall project cost is around $700, and the current cost is $3,100. For the design phase, it's $1,300, and development phase, it's $1,800. Thank you.
So next we will talk about the code. So this is our data, and these are the columns with the null values. So after removing the null values, so I have dropped the null values in all the columns. And yeah, this is the data cleaning where we remove the null values. So next we replace the ordinal categories with their string values. So here I have converted them to the string data types, and here you can see the ordinal categories are replaced with their corresponding string values. So we have done this for all the columns. Here I have removed the outliers from the dataset. So these are the columns with outliers, and after I have created a method to remove the outliers, and after removing the outliers, so this is how the columns looks like. So next I have done the analysis on states. So here so the top 10 states are Washington, Ohio, Florida, and Maryland and New York, where we have a lot of users with heart disease. Then I have also done the analysis on metropolitan counties versus non-metropolitan counties, where we have the number of heart disease cases is doubled in metropolitan counties compared to non-metropolitan counties. And for urban versus rural counties, we can see that the number of users in urban counties is a lot more than the number of users in rural counties.
Yes. Hello. So I have done univariate analysis for analysis. For that, I have imported necessary libraries such as pandas, matplotlib, and seaborn. I have loaded my dataset, and for numerical column, I have done descriptive descriptive statistics, histogram, and box plot. For categorical column, I have done frequency count and bar plot. So we can see that for age, we have minimum age is 55 and minimum is 18 and maximum is 80. And for the histogram, we can show that we have very less individual who have 20 to 30 age, and we have more individuals who have age from 60 to 80 in our data set. And according to bar plot for gender, we can see that we have more female in our data set than the male. For BMI, we can see that we have very less individual who have BMI nearly 50 to 20, and we have very more individual who have BMI nearly 25, and we have very less individual who have BMI nearly 40 or 40. Now Nida will continue.
So first of all, I imported pandas library, and then I've loaded my CSV file. Then I changed the indexes to just summarize all the data that we have, and then I also displayed all the column names that we have in our data set. So I did the first bivariate analysis was it's for the age versus heart disease. So the data gathered from 3,43,452 individuals. This shows the age on the x-axis. The age is categorized, and the blue bar shows the individuals without the heart disease, and the orange with the heart disease. So as can be seen from the graph, that as the age increases, so the people with heart disease also increases. Then I did for the gender versus heart disease. So here is the gender. So gender, like the female and the male. So overall, this means that men are more likely to have heart disease comparatively to women. And then I did the BMI versus heart disease. So in the BMI, we can see that as the BMI increases, so does the rate of heart disease increases. This one. And then I did for the exercise. So this is again exercise. The people who does not do any exercise and do have heart disease, do have less heart disease compared to the people who regularly does exercise. And then I did for the smoking status, and also for the alcohol consumption, for physical health, and for the diabetes, for the weight distribution, for the checkup, for arthritis, for AIDS, and for mental health. And depending upon the mental health, how does the individual overcome the heart disease? So that's it from my side.
So this is So I have created the main user interface where user will enter their health related information to get a prediction of their cardiovascular disease risk. So whenever a user enter their data like this, I have also validated the input fields, like if the age is 20, when any user predict the disease, it will show value must be greater than or equal to 0, same as for the all the options. These drop down must be selected whenever the user want predict the disease. It will show all the drop down must be selected, and all the values should be there. So this is the user interface that I have created. So that's all from my side. Thank you so much.
So that's all about our midterm presentation. Thank you.